Hello everybody. I'm going to demonstrate, or actually going to do two things. I'm going to show you the components that went into the power supply, um, give you a little assembly instruction, and then I'll do a demonstration of the various types that I've made. Alright, so when I talk about a power supply that supports the Bob Beck device and several other devices that I am in the process of building, I'm talking about the pillbox. I happen to have one just plugged in and connected here, and I will explain. Um, I've made these of various types. As you can see the 8.4 volts in here. I have a lithium-ion battery. It is fully charged, hence it's standing here. This is basically acting as a battery meter for the lithium-ion battery. But I could charge one. If I had a lithium-ion battery that was fully charged, and unplug this one, and I'm going to just find one that's not completely charged. Okay, here we got one. Here's another version of a lithium-ion battery. This one happens to be 600 milliamps. The one that's fully charged happens to be 550. This particular model I happen to have in the Bob Beck device that I'm presently wearing. I'm doing some back-to-back videos. I just did a video on this, that's why I still have it on. I'll wear it for a couple hours and then take it off. And you can watch the Bob Beck videos and read that part of the website to get a little understanding of what's going on with this. This charges, of course, as a 9-volt lithium-ion battery because that's what's inside it. So at any rate, we do happen to have a battery that's not fully charged, so I'm going to turn this on or plug this in, and you can see the meter is reading 8.2. Now, like I said, I've mounted these in various ways. I've mounted the meter inside. I've mounted the meter external. Here's an external version. It's not plugged in yet, and we will plug it in. Those are the two ways I've mounted it. I find that you can build this. It's more work mounting the meter external. It's a little more cost effective because this particular unit is a combo unit of a buck converter with a voltage meter combined all in one assembly, and they cost a little bit more depending on where you find them on the internet and so forth. So let's actually just do a quickie here. This is a 9-volt supply. It's not a very well regulated supply. It peaks out somewhere around 12.5 volts or 12 volts. The ripple peaks of the rectified AC in here. It's basically a bridge rectifier on a mini transformer. It's capable of providing roughly 200 milliamps. I use this for several of these devices. I don't use it for all my chargers, but I use it for the smaller lithium-ion battery units. So if I simply plug this into the wall, this extension cord wraps back to the wall, and turn the power on. And grab the right unit so I am consistent with my talk here, and plug this in. This will start creeping up slowly. It'll creep up to 8.3, 8.4, and then it will stop. Providing I have everything turned on. And we're not going to watch it creep up. If it's at the low side of 8.2, it could take 5, 10, 15 minutes. If it's at the high side, it'll flash to 8.3 very shortly. But I don't know where it's at exactly. And since we have this one here assembled, I'm going to take off the battery, and you can see it's now reading the charger. Keep it plugged in. Oh, I got a loose connection here. Okay, I'm going to have to work on that, fix that. So it's reading 8.4, but as soon as I connect it to the battery, boy, I have an appreciation for people who have the dexterity to do so many things with one hand. You can see it drops down to 8.2, and it will, like I said, creep up. I set this particular buck converter to only charge up. See, you can see it's flashing now to 8.3. To only charge up to 8.4 because that's what these 9 volts are designed to do. All right, so much for that. Let's talk about how we set these guys up and how we actually build them. So I'm going to unplug this. I'm going to unplug this, and we're going to talk about a basic unit, and I'll clean this mess up during the course of the conversation. The first thing I do is I go out and get myself a pill box. I don't care what color it is. They have various sizes. I've actually built one in a smaller pill box. You can see it's smaller than, it gets a little tight, and I found building them in this size pill box makes a real nice case. I cut this out with a X-Acto knife. The first one I built, I actually drilled little holes, and then I filed it, and what a pain that was. An X-Acto knife works very nice, very quick. You can get these things cut out, this hole cut out in about, depending how skilled you are, maybe 10 minutes. It's not very, it doesn't take very long. I drill a hole in the bottom. This is for the plug that you will be plugging your Vampire wall module into. And that just screws in. Drill a hole, and it's got a nut and bolt. Put it on the inside. I wire it up first. There will be a schematic. There is a schematic on the website on how this is wired, so you can download that. And it's a very, very simple circuit. Extremely simple circuit. So there's a couple of cases. Then I buy 2 components. I buy this 3-character 8-segment display that is basically a voltmeter. It reads volts, and I'll demonstrate. There's 2 wires. There's the unit. We'll just see if you can, hopefully you can get this all together. Flick this on the positive to the positive. And there you go. This one's reading 8.45. Now they're relatively close, but they're not perfect devices. Some will read 8.4, some will read 8.45. It depends. And I have units that actually have a little pot on the back that you can adjust. They're a little more expensive than these very basic ones. So if you have a standard that you're calibrating against, then you can make them all identical in their reading from one unit to the next. The next component is the buck converter. Now I buy the buck converters in sheets, and here's a sheet of buck converters. And let me talk about a buck converter. What is a buck converter? A buck converter is a unit that uses an inductor, and that would be this little guy right here that I'm pointing to collect the current, and basically in combination with a switching power supply, and that would be this little IC. It's a 5-wire IC, and the specs again for that will be on the website. You can build these yourself. You don't have to buy them pre-made. With a little trim pot, all wired together with a couple of caps and a couple of resistors. Allow you to take a wall module or a supply source ranging from typically 24 down to 3 volts and convert that would be the output of the supply, and convert it down to something lower than what the supply source is. For example, let's say I had a 12-volt battery and that was my supply source, or I had a 12-volt wall module. By the way, 12-volt wall modules will give you a little bit more than 12 volts. They'll give you like 15 or 16 peak to peak off the bridge rectified DC that's coming out. But let's just take a 12 volt battery and say I needed to have a 5 volt source. I could buy one of these buck converters. It's got 2 input leads that you would solder a terminal connector or whatever that would go directly to the 12 volts. And then you turn the pot, and on the output you could adjust it from 12 volts down to roughly 3 volts. Maybe a smidgen lower, maybe 2.7, maybe 2.5, but certainly you get to 3 volts without any problem whatsoever. And what's nice about a buck converter versus this guy, that you can hardly tell the difference from, and I'll talk about this in a second, is that you can use one wall module like this. This happens to be a 12 volt wall module capable of half an amp, 60 capable of 500 milliamps at half an amp. And that could be a single source supply unit, and you could turn the pot if you were going to adjust 12 volt batteries, turn it down if you were going to adjust 9 volt batteries, or turn it down if you were going to adjust 4 volt or 3.7 to 4.2 lithium ion batteries. You don't have to charge lithium ion batteries. You could use this, as I will demonstrate later in the second video, to charge a 12 volt lead acid battery. And I'm pointing to that's a corner of a lead acid volt battery. I'm not going to pull it into the display right now. So this is a buck converter, and I did make a comment versus a step-up converter. Now, a step-up converter works exactly opposite of a buck converter. It will take 3 or 4 volts, typically minimum voltage is 3, and it will allow you to adjust it up to 38, 40 volts typically. So on the input, for example, on this particular one, I have a 9 volt typical style plug, and I got the outputs here. I could turn this pot and I could get nothing lower than 9, but I could get 9, 10, 11. I could dial it all the way up to about 38, 39 volts, maybe 40. And this is the device that I use in the Bob Beck device. You can also make a charger out of this, but then you're a little bit more restricted on what type of wall modules you're going to be using in combination. They're not quite as flexible as the buck converter to make chargers, but they make fine chargers if you're going to make a dedicated one. So and you can't physically tell the difference because the switching power supply chip that they use on the up converter is the same chip that they use on the buck converter, just a slightly different wired configuration. And when you go to the website and you see the chip that's used, or the IC that's used, you can download the specs and you can get into it if you have a geeky tendency, or you just want to know more or learn more, whatever works for you. All right, so I'm going to put this out of sight because we don't want to accidentally use that or make a mistake and describe something that I'm not the wrong thing. So here's a buck converter. I buy these in sheets. I make these power supplies for myself and to match up with the Bob Beck device. Whenever you get a Bob Beck device, you're going to need to have a power supply because you're not going to be opening it up, swapping in a 9 volt alkaline battery. Just use the lithium ion that's in there. And I'm going to take these and put them out of the way. And what do we have for video here? We've got 13 minutes and 50 some odd seconds. I'm going to stop this and make a second video.